You say evolution is a fairy tale for grown-ups. Why do you make that claim?
Well, the spontaneous origin of life starts with once upon a time there was a collection of chemicals that self-assembled all by themselves, became a little bit more complex, then self-assembled again and became more complex, and then eventually out pops a living organism. And there's no scientific evidence to support this, so it's a fairy tale story. Unfortunately, it doesn't have a happy ending.
Doesn't chemistry and genetics prove life evolved over time?
Actually, it proves the complete opposite. Let me give you the perfect example. I'm going to give you a bucket of all of the chemicals that you want. I can put them on 1 billion planets for 1 billion years, and it's going to be very, very boring for me because I won't see a single living organism evolve. Science pushes it in the other direction.
How could so many scientists be wrong about evolution for over 150 years?
I love this question when I get it, and I get a little bit cheeky, so forgive me here.
Dr. Stephen Grocott, as a chemistry professional, you claim that evolution is a just-so fairy tale for grown-ups. It's quite a bold claim. I know there's a lot of other chemistry professionals who probably disagree with that. Why do you make that claim?
Well, let's look at what a fairy tale is. It starts with a once upon a time, and then it proceeds to an imaginary story lacking in evidence, and then usually ends up with a "and they lived happily ever after." Well, the spontaneous origin of life, that's the creation of life from non-living chemicals, starts with once upon a time there was a collection of chemicals that self-assembled all by themselves, became a little bit more complex, that then self-assembled again and became more complex and more complex and more complex, and eventually, in this just so story, out pops a living organism. Now, it doesn't have the happily ever after, but it's a fairy tale because it's lacking evidence. Now, it's not meant to be insulting to scientists. I used to believe this, and now I look back upon what I used to believe when I read things like Evolution's Achilles Heel, or I watch the DVD that goes with that, and I think, some of the stuff I used to believe in without evidence, it was almost embarrassing.
Right. Now, we've had a session on this before where you talked about many of the reasons why chemical evolution can't be so. But just so people understand, where are you coming from? What's your background to even say these things?
Well, all of my professional career has been wrangling chemicals, trying to get chemicals to do the things that you want them to do, and it's pretty tricky. And that goes back to when I did a PhD in chemistry, and if I'm going to use the really polysyllabic long words, it was about reactions in stereochemistry of octahedral metal complexes, of ruthenium-2 and cobalt-3 containing chiral ditertiary phosphine and arsine ligands. Now, I don't say that to tongue-tie people, but I started out my professional career as a PhD qualified scientist. I've worked as such in the field of chemistry, industrial chemistry, for 40 years. I've published many scores of peer-reviewed papers and patents. I still supervise and co-supervise PhD students and postdoctoral researchers, and I've spent and are spending hundreds of millions of dollars on research and development in peer-reviewed real-world science. And I say this for one reason, and that reason is just to show that real scientists working in peer-reviewed, valued areas believe in the Genesis account of creation.
So with your background in science, why are you interested in chemical evolution?
Well, two reasons. I like talking about this. Firstly, I'm a science tragic. And I love talking about science. And I'll use as an example, my wife and I are on a river cruise down the Rhine River. And my wife is looking at the castles and the vineyards, the natural beauty, and she says, "That's beautiful." I'm looking on the other side of the river where there's these giant industrial plants, and I look at that and I know the complex chemistry that's occurring in them, and I think that is beautiful. So I'm a science tragic. I love talking about science. But secondly, to talk about the spontaneous origin of life, I like talking about that because that is just so important.
Okay. I hear people say that life can't come from non-life. Why is this such a big deal for people who believe in evolution?
Well, for people who believe in evolution, they obviously have to have a start, and the start is that non-living things assembled into living things. Now, if there's proof, if there's evidence, if there's compelling evidence that non-living things do not spontaneously form into living things, then that only leaves one solution. And that solution is that there was a designer, there was a creator, there was a divine force that forced against the laws of physics and chemistry for these chemicals to assemble into a living organism. Now, if there is a creator, if there is a designer, then all of a sudden people have to ask the very uncomfortable question, what is my relationship to this designer? It's very confronting. It was very confronting for me.
Well, let's have a look at some more of I've got some more questions about chemical evolution before we get into some of the faith-based things. Another word I've heard of is abiogenesis, thrown around with the chemical evolution idea. What's abiogenesis?
Scientists love using big words for simple things. Abiogenesis just means that non-living things all by themselves became living things. That's all it means.
Okay, and you mentioned living. That's the next thing I want to explore. What makes something alive compared to something like this mug on the table?
And questions like this are actually really good because it makes you think about them. Most people would say, well, it's obvious to me what a living thing is, but define a living thing. A living thing is something which can respond to its environment. It can repair itself. It can replicate itself. It can gather its own food or consume its own chemicals. It generates waste products and it eventually dies. That's a living thing. Big contrast to non-living things. Seems pretty obvious, but it's worthwhile keeping that in mind as we go through this discussion.
Right. So I guess that rules out things that, generally speaking, if something's living, you expect it to move. But then you got things like, well, there's electricity and even lava in a volcano is moving. And it seems like it's alive, but you'd say that's not living, right?
Yeah. So lava is a good example. I've been fortunate enough to go to the big island of Hawaii and watch a volcano erupting and stand near flowing lava. And flowing lava flows from the natural laws of physics and chemistry, the laws of gravitation and viscosity. And those laws govern what happens to the lava. Now, the laws of physics and chemistry that govern how chemicals behave do not lead them to form living chemicals or great complexity. But the laws of physics and chemistry, etc., govern what happens to electricity, governs what happens to lava. Those same laws do not lead to life from non-life.
We'll get back to the interview in just a second, but first, I'd like to thank you for watching these videos. And if you aren't subscribed, please subscribe and ring that notification bell, as it helps us create more content like this. Let's get back to the interview.
Now, another side of things, is it just a matter of how complex something is? And if it's complex enough, call it life? Or is there more to what that complexity has to do for it to be called life?
Yes, so for life is a lot more than complexity. You've got to have something called specified complexity. So you've got to have the right form of complexity, and it's got to meet those criteria for a living organism. It's got to self-replicate. It's got to respond to its environment. It's got to be able to take in ingredients or food, spit out waste products, etc., etc. As an example that people use for complexity or apparent design when there is no designer. Early in my days after completing my PhD, after I'd become a believer in a divine origin of life, a professor used on me the argument of crystals. Now, he was an expert in crystals. And he said, well, take a crystal, look at the complexity in a crystal, this highly complex structure. And in actual fact, it's got complexity, but it's a lot more simple than people think. Crystals come in the form of what's called a unit cell, which contains a small number of atoms, and you just replicate that. It's 3 dimensions, so you replicate it in the X, Y, Z dimensions. And however big X, Y, and Z are determines the size and the shape of that crystal. So it's actually quite simple. It's rinse and repeat, rinse and repeat. That's all it is. Now, if I take a crystal and I chop it in half, I've still got the same unit cell structure. It still responds the same way to X-rays. It's got the same properties. But it's two identical halves. Now, if I take a living organism, take a lab rat, I cut a lab rat in half, I do not have the same information in each half. I've got two halves of a dead rat, and they've got different information in each. And I can't combine them and make it living again. So there's a big difference between the complexity of a living organism and the complexity of a dead organism like a salt crystal that you'd find in your pantry.
So you mentioned before the word specific complexity. I'm just trying to put that into context with your analogy with the crystal and the poor lab rat. How do you make sense of specific? Is it specified?
Specified complexity.
Specified complexity. How do we understand that with that example?
So living organisms require a unique type of complexity. You can form a random assembly of polymers from the precursors supposedly to the natural origin of life. You form this random collection of polymers. A vanishingly small percentage of those have what it takes to be useful to a living organism. So that is a specified complexity. So it's not just complexity that you get from a random collection of polymers. It's complexity that is unique and required for living organisms. Let me use an analogy. Paper and ink. I can throw a bunch of paper and ink together into a blender, and I'm not going to end up with Shakespeare's plays.
No.
I'm going to end up with a lot of complexity. It'll be all this order that will be very hard for somebody to replicate, but it won't contain specified complexity. Like an explosion in an ink and paper factory does not produce the Bible. You need an intelligence and a design to create that specified complexity that is a part of living organisms. The signature of that specified complexity is obvious.
Okay, thanks. That makes sense. So we've got already some issues I'm seeing, but of course, I imagine evolutionists have been aware of these issues and they've got theories. Can you just tell us, how do evolutionists say that chemical evolution happened?
They start with simple chemicals, or what they call simple chemicals. So take an amino acid, and they say that amino acid combines with another amino acid, which then combines with another. And before you know, you've got 3 amino acids together, and that's called a tripeptide. And eventually you'll get to 50 amino acids, and you'll call that a protein. And you'll do the same with sugars. You combine them and you get a monosaccharide, a disaccharide, a trisaccharide, and you end up with polysaccharides. And then you combine them with some phosphate, and you get some other molecules, and then you combine all sorts of other molecules, and eventually you get all this complexity that has the right complexity to form a living organism. So that is the speculation. Now, unfortunately, that flies in the face of all what I would call operational science. Now, at this point, we probably should define what science really is. Science has got a number of characteristics, which include it must be falsifiable. So there's no point in having a theory which you can't falsify. And it must be falsifiable by testing or experimentation. And that test or experimentation must be observable, and it must be repeatable. So if we do that experiment in this room, or we do it on the other side of the world, you need to get the same result. So falsifiability, testability, observability, repeatability. And you do all that and you apply that to the spontaneous origin of life from non-living chemicals, and you find it wanting.
Right. Well, I've heard of some ideas, and I thought I'll pass these by you. And this is from an atheist. I actually read a book from Richard Dawkins not long ago called The Blind Watchmaker. And the way he explained it, actually, I think I could see why there were some issues. But it did sound very convincing the way that he wrote it. And I thought, if I pass some of these ideas by you, and you can help us understand how to think about it. Yeah. One of the things that he mentioned was an idea of chemical evolution to get to, his idea is that once you get to DNA, happy days, evolution is fine. I think there's problems still after that, but let's just say, what if we can just get to DNA? And he talked about a phrase called RNA world. Have you heard much about RNA world?
Yes, it's one of the most popular theories at the moment,
right,
for the spontaneous origin of life. And Richard Dawkins is a very intelligent man and he's a great communicator. But what I'm going to say, it may sound like I'm denigrating him, and I'm not trying to do that. But let's start with DNA, deoxyribonucleic acid, the so-called instruction manual for life. Now, for a long time, scientists believed that DNA must have come about all by itself. And they found themselves beating their heads against this wall of DNA complexity. It was just so impossibly difficult that they abandoned the DNA hypothesis for the origin of life. And they went to something called RNA, ribonucleic acid.
And is RNA very different to DNA? They sound similar with the acronym, but are they completely different?
There's a lot of similarities. DNA has got the nucleotides. They wind in a helix, and they pair with another helix, and you end up with the so-called famous double helix of DNA.
That's like a twisted ladder.
Yeah.
Sort of.
And RNA is a single helix. And here is the first problem. So this single helix is very different from the double helix in a couple of important ways. The first is that the double helix, the two helices, they actually help stabilize each other. So RNA doesn't have that second helix stabilizing itself. So it's between 10,000 and 1,000,000 times less stable than DNA in water. Horror of horrors, the water that you need for life decomposes RNA. It's got a half-life of a few minutes. I mean, it's not a stable, it's a very unstable molecule.
Yeah.
It gets even worse than that. I'm not even being pessimistic here. Some people have tried to invoke the presence of clay minerals will template the RNA, it'll stick on it, it'll stabilize it. Well, unfortunately, it goes the wrong way. RNA, in the presence of clay minerals, becomes 1,000,000 times less stable than DNA, and now it's got a half-life of tens of seconds. And then on top of that, you throw in the ions that you would expect in the primordial soup, the so-called primordial soup, things like magnesium and iron, and they destabilize RNA even more. It now has a half-life of 10 seconds. So the DNA world was banging its head futilely against the wall of complexity. The RNA world is banging its head futilely against the world of instability.
You're right. So it's even more unstable than the DNA, and they're having to appeal to the RNA for chemical evolution. Now, can you explain what stability means in terms of? Does that mean it's it's wobbling around, or it's actually falling apart, or what does stability mean for RNA?
Good question. Sorry, I should have explained that. It's a chemical instability. It falls apart. It disintegrates. So you've got hundreds of these individual chemicals linked together. They disintegrate. They fall apart. And then the individual bits that fall apart, they then decompose into other chemicals. It's incredibly unstable.
Right. So it's like the chemical bonds. They break, and
they break. They want to break. You need specially designed complex chemicals that you only see in biological organisms to stabilize them and hold them together.
Yeah.
So to form them, you need these special chemicals to hold them together. But those special chemicals are only formed by the instructions that come from the RNA. So you've got a circular argument here, and I'm afraid it's a failed circular argument.
Yeah, now that's an interesting point. You're talking about it's not just the RNA or the DNA. It works in junction with other things. What are these other things that you need for them to even have functionality?
They are complex enzymes, collections of proteins, very long proteins, 60, 70, hundreds of amino acids long, 2 amino acids combined into many. So it's complex proteins, and it's things called ribosomes that are a mixture of proteins and nucleotides or bits of RNA. I'm being a bit oversimplifying here. But you need all of these complex, really complex, unstable molecules to form these other complex, unstable molecules. So they need each other. It's chicken and egg. Without one, you can't have the other. And you need them both together at the same time in relatively high concentrations. And you need them in an environment that's a killer environment, water and temperature and light and oxygen and all these other things.
Right. So when they talk about primordial soup, I'm imagining that they're saying, oh, by chance, you happen to just have, what is it, like the ribosomes and the RNAs and DNA? Is it even at that level they think, or is it lower level than that? What do they mean by primordial soup?
So primordial soup will start simply. You can naturally form some simple amino acids under certain conditions that are speculated to be present in the primordial soup. But I'm going to use an example. I'll take amino acids which form into proteins. So you combine two amino acids. They join together and you end up with a dipeptide. And you end up with a water molecule. And you've already got a lot of water in your primordial soup. That's what's in your soup. Now, there's a chemical principle. It's a law. It's called Le Chatelier's principle, which says that you put more water there, it's pushing this reaction back the opposite direction. So the two amino acids combining to produce a dipeptide and water, the more water you got there, it's pushing it back the other way. So the force is going the other way. You try and add a third amino acid, you spit out another water. It's more water pushing. By the time you get to 2 or 3 or 4, the first one's dropped off or it's split in two because water is an enemy. So in primordial soup, you've got all this water. Water is an enemy to the combining of these simple molecules into complexity. It only happens in living organisms because you've got special enzymes, special chemicals there, which protect those two amino acids getting together and they exclude the water. It's a unique design.
I hope you're enjoying this interview so far. Creating content like this takes a considerable amount of time, effort, and resources. We're passionate about getting this message out and we want to keep bringing you more videos like this one. But here's the thing, we need your help to make that happen. Your support, no matter how big or small, will help us cover our production costs and enable us to continue creating impactful content. To support this project, just use the link in the description below or the on-screen prompt. We're so thankful for your support.
So it's not looking particularly likely for primordial soup, but I have heard some other theories. One of these theories, it's the name of it sounds wild. It's like extraterrestrial life, or essentially the life came in off a meteorite or something like that hit the Earth. And let's say that chemical evolution of life happened somewhere else that we can't see. And then the life pops up there. Have you heard of that one? Are there issues with that theory?
Yeah, it's quite an old one. In the beginning, there was ET. It actually goes back to the discoverers of the structure of DNA, who recognized the vast complexity in living organisms and said it is so vanishingly improbable, it's impossible for it to have occurred on Earth. Therefore, it must have occurred somewhere else. Now, to give it some scientific respectability, they call it panspermia. So life came from outer space. But all that is doing is transferring the problem that they have on Earth to somewhere else in the universe. And they're appealing to time and chance on billions of worlds.
Right. So time and chance, I have heard some people when they see something that's like impossible and they go, but it must have happened. And they just go, oh, well, there must have been infinite time, or not infinite, but close, a long, long time. And all of a sudden you do the maths and they go, oh, now it's a certainty rather than something that's impossible. Is that sort of what they're trying to appeal to? Does that even work?
Yeah, I'll split that into two. We'll deal with the chance part and then we'll deal with the time part.
Sounds good.
So the chance part, you can actually determine. Chance sounds like you're random and rolling a dice, but it's actually a lot of science in the probability, and it's called chemical thermodynamics or statistical mechanics. So you can talk about the probability of two amino acids combining in water to form a dipeptide, and 3 and 4 and so on and so forth. And you can calculate the probability of spontaneously forming just a simple polypeptide. And we also know roughly how many atoms in the universe. I'll give you a big number. It's 1 followed by about 80 zeros. Now, the chances of forming just a simple peptide is less than the chance of you picking out the one unique atom that I've marked with an X out of the 1 followed by 80 zeros atoms in the universe. That's how small it is. And that's one peptide. You need hundreds of them. And you need the polysaccharides. And you need the ribosomes. And you need the RNA. And then you need the DNA. And you need the cell walls and the cell wall design for ion transport. You need all of this. So you can get to probabilities where some statistical mathematicians actually define impossible as less than 1 in 1 followed by 80, or some say 100 zeros. So from a chance perspective, I call that, and many people call that, impossible.
Yeah, but now the second point, because some people are saying, yeah, but what if we have a lot of time? Can't we kind of bring that uncertainty number down if we have lots of time for it to occur?
I love this question when I get it, and I get a little bit cheeky, so forgive me here. Time is an enemy. The train's going in the wrong direction. I can give you a bucket full of DNA or RNA of living chemicals, of chemicals derived from living organisms. I can give you this bucket full, and I can leave it there as long as you want. It is not going to turn into life. The train's going the wrong way. It's actually going to get less complex. It's going to decompose. I don't mean biologically decompose, because we've got no life there. I mean it will chemically decompose. There are hydrolysis reactions. There are cross-coupling reactions. There are all this chemistry that goes there that's driving the train the wrong way.
Actually, that makes sense, because you talked about earlier the water. So when you get, is it the peptides or the...
Yeah.
And as you get longer chain, you get the water that's created, or that is formed from it. I don't know what the right terminology is. Or created is probably the wrong word to use, but the water pops out, and then more water is fighting against it, growing the chain.
Yeah.
So I can see what you mean. Well, it's not naturally going to want to continue growing, because naturally it's actually suppressing the growth anyway. Thanks for clearing that up. That makes a lot of sense to me.
Yeah, you just reminded me. I remember conducting chemical reactions in some of the research that I've done, where a water product has to be removed at the same time as it is produced in order for the reaction to continue going forward. Because if I left the water there, it's pushing it back the other way.
Right. So you've pretty well got to supervise the experiment and interact very carefully to make sure that it actually succeeds.
Yeah, it requires quite a lot of intelligence and me standing on the shoulders of other scientists who figured some of these things out.
Yeah, wow. So life from non-life doesn't sound very possible at all. Impossible. So what's the other alternative? We've got, things can't just evolve from nothing. And I hear other people talk about there being a designer. Can you talk more about that?
Yeah, so I see only two possibilities. Life arose by chance, or it arose by design. I don't see how people can think of other alternatives. And I think that's generally accepted. And that's why believers in a divine origin of life like me often get attacked by people because they don't like the idea of there being a designer. They like things to have arisen by chance. If there were other plausible or more acceptable possibilities, they would be floated. So in simple terms, it's either arisen by chance or by design. And there are many people who talk about different alternatives for the designer, but the designer that best fits the evidence that I see is the designer that's communicated to us in the first verses of Genesis in the Bible, in the first verses of the Gospel of John in the Bible.
So this is kind of moving to faith, but like you said, you're weighing the evidence up. It's not just, I want to believe this because that'd be nice. You're looking at the evidence and going, this makes the most sense of reality. But a lot of people, they would say that it's very illogical to believe in God, because there is, there's elements of the Christian faith Well, it's called the Christian faith. There's faith involved. What do you think about that when we talk about faith? And scientists sometimes hate the word faith, but is it something that is kind of an issue with Christianity, or is that something that we see on both sides?
Yeah, it's definitely something we see on both sides. Let's go back to what the definition of science is, that it's falsifiable, it's testable, it's observable, and it's repeatable. Now, evolution is not falsifiable, testable, repeatable, observable. Who was there to see the first fish emerge from the ocean, and can you replicate that experiment? We can't even make synthetic life in a laboratory ourselves unless we start with some living organisms and modify those. So evolution, the spontaneous origin of life, is not a science-based question. It is a faith-based question. Now, a divine origin of life, likewise, is faith-based. But you can use science, good, hardcore science, to support or reject either belief system. And I have done that as a scientist, as many have, and what stacks up is there is a divine origin of life. And to quote Sherlock Holmes, he said something like, when you've ruled out everything that seems possible and all that's left is what seems impossible, then that's what happened.
Right. Yeah, I like that distinction that you made about it's not just some people have faith and some people don't have faith, and they're just scientists. Everyone has to have faith in some things, that especially with historical science. They can't can't just follow all the evidence and say it's all proven. So yeah, that makes more sense to me now. Yeah.
Well, I mean, that's where I was. I didn't like having to face the question about where did life come from. During my PhD, there was a more senior PhD student. He was closer to finishing his PhD than me, and he was a believer in a young earth and a divine Christian God origin of life. And he used to be mocked and he used to be ridiculed by the other PhD students in the laboratory. And I probably contributed a bit to it as well, but I used to be really uncomfortable seeing the mockery that was given to him, because 100% of it was directed at him as a person. Not once in the years in the laboratory with this person did I hear someone present a scientific response to the evidences that he gave. Not once. Now that made me really uncomfortable, because I thought there's something here. And slowly germinating seed, but it took me a long time. I eventually looked at that and I go, there is a divine origin of life, and I need to find out more about this.
And how did you, if you don't mind sharing,
Yeah.
what was that journey like when you see there's something different about this creationist, this Christian at university studying science, and they're getting mocked, not so much because of their interpretation of the evidence, but just because of them as a Christian. And you're uneasy about this. What did you do then? How did you react to that and follow up on that?
Shamefully, nothing. It was years and years of slowly germinating away, where a bunch of things came together. So my science understanding and being uncomfortable about what I had been taught in school and what I just swallowed and had not looked for the evidence, coupled with a bunch of life experiences. I mean, I was fortunate enough to have gone through school, top student, uni top student, married a beautiful lady who became a medical specialist. I was eminent in my field as a scientist. I traveled the world. I had all the credibility and all the authority, but it didn't bring me any satisfaction. It didn't bring me any peace. And I combined that with the scientific background that I had, and I said, okay, I'll finally marry the two together and put the two and two together, and I got the obvious.
Yeah, and so that led to you becoming a Christian.
Absolutely, yeah. And the joy that it has brought me, even from just a scientific perspective, I look at science through a different lens now, and I see beauty, I see structure, I see design, I have insights, and I understand things from a much deeper and more rewarding perspective than I ever have. As I continue to do science research, and I've been doing it for 40 years, I still get a thrill from discovering what makes things tick and seeing the designer's hand in the way that the world works.
Yeah, that's quite a journey you've been on, and I'd be interested to hear what you think about, or what advice you would give. Let's say someone's watching this and they could be at the stage where you're at, where they're just a little bit uncomfortable to see these creationists, the Christians, being mocked, not for their science necessarily, but more so just because they're Christians, and they're going, well, there's something a bit odd about this, but there's still for yourself, still took a while. Well, what's the next step for someone who's a bit challenged by this and unsure? What do you think they should do?
Well, the first thing I'd recommend is don't join the mockers. Step back and say, have some reasonable questions been asked here? Has some reasonable evidence been asked? Do some research. Creation Ministries website is a rich place to go and get questions answered with peer-reviewed literature and references to secular literature as well. Do some research. Ask yourself the genuine question. Make yourself uncomfortable. Growth happens through discomfort. You're going to have to be discomforted. You're going to have to be uncomfortable. I was uncomfortable. I think most people who come to a belief that there is a divine origin of life went through a stage of discomfort, because I don't know about you, but I think most people love being their own boss. I loved being my own boss, and it wasn't until I got to the point where I realized that that wasn't bringing me much joy anyway, coupled with my scientific discomfort, that I put the two together. So I encourage people, be uncomfortable, ask some questions, don't mock, ask the questions and see if you can get some answers that satisfy you from a science perspective.
Yeah. Oh, thanks for sharing that. That's I think that'll be really encouraging for a lot of people. So just to summarize, we talked so much about chemical evolution. Can you summarize for us chemical evolution and why scientifically you think it's a fairy tale?
Yeah. So back to the fairy tale. Chemicals, dumb chemicals. That's perhaps insulting to chemicals, but they can't be insulted because they're not intelligent, they're not alive. So dumb chemicals do not self-assemble into complexity and greater complexity, and in particular into the specified complexity that is required for living organisms. They do not self-assemble. All the forces of physics and chemistry are pushing in the opposite direction. It's inexorable. It's unresistible. There are no exceptions to it. You cannot get rich by withdrawing from the bank. You start with complexity, it gets more simple. So it's a fairy tale. Now, unfortunately, if that's the belief system that you have, that fairy tale may end up with a not happily ever after, but a bad ending to the story. Whereas the divine origin of life explains how that complexity, vast complexity, so much complexity that we're only scratching the scratch on the surface with the stuff we talked about today. So much complexity arose not by chance, but by design. Scientifically more satisfying and also theologically consistent with what the Bible says.
Well, thanks for summarizing that. Now, you mentioned a documentary, I think it was right at the start. You mentioned evolution's Achilles' heels, and we actually have it here on the table. Can you talk a little bit about this documentary and what people will learn from it?
Yeah, so Evolution's Achilles' heel is a great summary of a bunch of the key aspects about how life came about, how life evolved, how ethics and morality evolved. There are 8 chapters in there. Chapter 3 is my favorite as a chemist scientist. It's about the origin of life, the origin of the first life, written by a brilliant scientist, Dr. Jonathan Sarfati. But there are many other chapters in there on DNA, on genetics, etc., etc. So you can read the book, watch the DVD. I think it's available as a download as well. That has got a wealth of information. The Creation Ministries website, it's got a great search engine in there. Type in your question. What about life from other planets? What about DNA? Couldn't that arise by chance? What happened to the dinosaurs, etc.? Do real scientists really believe in this sort of thing? You can ask any question you want, you'll find answers.
Excellent. We've got a lot of resources available for people, and I found that documentary very helpful for myself too. And if they want to watch the Evolution's Achilles Heels documentary, we'll actually put a link in the description below, and people can click on that and they can watch the documentary for free. Thanks so much for joining me today, Stephen.
Thank you, Michael.